Welcome to the GR4Alps Output 2.1, the Alpine space-wide map of decision structure of all involved and relevant actors. For the innovative GR4Alps research results, we strongly aim to transfer this new knowledge to relevant actors who have influence on natural hazard risk management. To achieve this goal, we identified, assessed and mapped actors and their networks in the first step. In the second step, we used the gained information to targeting actors on selected places and with tailored scientific information. For this process, we followed the Research-Integration-Utilization model to answer one of the most important questions in transdisciplinary research projects: how to reach the different actors from society and state to transfer their innovative knowledge. To answer this question sufficiently, we need to know which actors might affect natural hazard risk management and protective force, and which interests they have. To determine the interests of actors, we applied the ecosystem services approach. Ecosystem services are the benefits people obtain from ecosystems. In regard to natural hazard risk management in Alpine space, we used an ecosystem services classification with 4 classes, such as regulating services, provisioning services, supporting services, and cultural services. The ecosystem services give us the first link to the individual or collective actors that might be affected by the ecosystem services provision. This ecosystem services perspective builds up necessarily on actors who have a stake in the issue of natural hazard risk management. The natural hazard risk management issue is linked to achieving actors' goals, objectives, or conditions to which specific ecosystem services can contribute. Both user and regulator can benefit from ecosystem services or influence ecosystem services in different ways: by direct use, primarily by harvesting, consuming, or even producing services, or by indirect influence exerted through the decision-making system. Governmental actors themselves are responsible by their mandate for the public task of managing, maintaining, restoring, or distributing ecosystem service related to natural hazard risks. These tasks become constitutive for the social role of regulators and links them to various collective actors, whose specific goals, objectives, or conditions result in a variety of ecosystem services related interests. User instead primarily producing, harvesting, or consuming ecosystem services. The social role which an actor has influences the formation of its interests and limits the available sources or political instruments to enforce their own interests in decision-making processes. The fundamental distinction between users and regulators is in which way and manner they are able to act to achieve their interests and what kind and extent of power sources are available for them. In the graphic, the role of science is not visualized, but it includes the provision of innovative natural hazard risk management strategies to regulators or users. Those can accept or reject this scientific information, and after merging it with their existing knowledge and experiences, the new knowledge emerges, which is used to enforce their own interests. The composition of actors who can affect natural hazard risk management is different in each pilot action region, but follows the principle of regulators and users, which we had shown in the slide before. The absolute number of actors intervening in natural hazard and risk management also varies considerably, from 10 to 15 up to 13 in each pair. In this slide, we picked out some examples of actors, which we can find in the most pilot action regions. But for processes and operations related to the management of natural hazard and protection forests, different actors and networks are important. These actors and networks we can specifically use to transfer our GR4Alps research results. Detailed lists of actors can be found at the GR4Alps. Thank you to the GR4Alps researchers who hardly worked on the development of the broad set of research products. I only picked out some in the slide on the right side to demonstrate how they might get into praxis. The bad news is that only very few practitioners will make use of the GR4Alps research products. This happens quite often within knowledge transfer processes. The good news is that we have multiple opportunities to integrate the results into praxis. These opportunities are raised by the great number of affected actors in the field of natural hazard risk management, represented on the bubbles in the left graphic. All these actors have different interests and therefore they could be involved in various interest conflicts. Actors' compositions and relations might differ from the specific field and task to manage. In this slide I only present an example which could exist in praxis in a certain pilot action region. For the knowledge transfer process, the research results have to be brought in praxis. This means that the scientific part, the scientific truth produced by the GR4Alps researchers, is part of a practitioner solution, which is represented as the S and the graphic on the left side. Our main assumption is that acting of stakeholders is an interest-driven process. Here, the research products can be integrated into praxis by two different processes. First, convincing actors, which is represented as the triangle, and secondly, due to power processes by forcing actors, which is represented as the stars on the left graphic. In society there exists a nearly unlimited number of micro-power relations, in which one person is able to influence the action of one or more other persons. This is represented by the different sizes of actors in the graphic. But these power relations could change, an example, depending on time or depending on a windows of opportunity or due to structural changes. The described assumptions can be utilized for knowledge transfer tasks. This is captured by the novel RIU model for knowledge transfer. It takes the power relations of actors into account, which will be completed by so-called information channels, where stakeholders communicate to exchange information within the utilization phase. The RIU model conceptualizes a specific process of integration between research and utilization in praxis to facilitate effective knowledge transfer. Integration is the critical step between research and utilization, where successful knowledge transfer is a hypothetical process of different selection steps. Integration is the orientation of research toward practical and/or political problems. This phase is bidirectional, with two main questions: that of the demand practice has for new research contributing to innovative science-based solutions, and that of which research results could be selected according to their relevance in solving practical problems. Activities in integration and research typically alternate between both phases and can be visualized by means of production lines for the process and for the time dimension before a finalized solution is delivered into utilization and before specific science-based action by an actor develop practical relevance. Within integration, actors perceive their typical different roles as researchers, societal, market or governmental actors, each with a corresponding set of interests, values and norms. To a great extent, interests determine all action of individual actors or groups and are defined as an acting orientation, which designates the usefulness for an individual or group that will be obtained from a scientific solution or an object, like a direct object protection forest. Bidirectional selection happens in so-called integration forums. We define integration forums as places which are formal or informal settings where practitioners and political actors meet in order to exchange science-based information. The bidirectional selection takes place within the integration forum and within the composition of its actors. Therefore, this is mainly a power process by the most powerful actors. Often, several steps of adaptation of the research results are necessary. Integration forums specify entry points to establish practical relevance by addressing actors selectively. This table discriminates between existing, hybrid and new integration forms. We use the truth table format to classify the forms, and for that the point of view of the research project is crucial. An existing form has a link to science and is known by the project, like legally foreseen advisory boards. A hybrid form is a form that might exist and have a link to science, or it might be established but is unknown to the project yet. An example is an ad hoc task force for occurring natural hazard events with major damages. A new form has yet to be established by the project and will develop a link to research by the project. An example, a roundtable or workshop format organized by the project. Here, science has to be added to a group of actors from the fields. By using integration forums for knowledge transfer, a research project can play an active role in selecting actors and by choosing or creating specific forums. A forum might be linked to a single actor or to various actors. In the GR4Alps project, the identification of forums built on the pre-analysis, the interest analysis, the conflict analysis, power analysis, and observations in conducted integration forums. This set is used to identify promising stakeholders in regard to the potential to implement ecosystem-based solution for natural hazard risk mitigation and in regard to the project's first research results. An example, the modeling of the protective effect of forests against avalanches in a certain area. Here we are looking from the perspective of science to knowledge transfer. Our aim is to improve the knowledge transfer process from the viewpoint of a research project. Therefore, we want to draw the researchers' attention to stakeholders. This does happen by a sound pre-analysis to analyze actors and actor settings more precise. These 5 steps should be carried out in the planning phase or at latest at the beginning of a research project. The steps are necessary to gain the empirical database for knowledge transfer. In the first step, we aim to investigate the different roles which can actors have within its interest sphere. On the one hand, we have the role of a regulator, who is responsible by mandate for the public task of management, maintenance, restoration and distribution of ecosystem services. On the other hand, we have the role of a user, who is harvesting, using or consuming different ecosystem services. The next step identifies and map affected actors. Step 3 to 5 analyze actors precisely in regard to their interests, conflicts and power. Having this empirical data, we can link specific scientific information with stakeholders inside integration forums. Linking scientific information with stakeholders inside integration forums take place by prioritizing stakeholders for knowledge transfer. Firstly, a coordination process between the interdisciplinary research consortium is needed to select promising actors and to select the relevant research results for these actors. Secondly, we should identify and classify the different types of integration forums in a specific field of work, like natural hazard risk management. Thirdly, we have to lean in appropriate integration forums by trying to seek access to the forum through key actors or through participating actors. All aforementioned steps we summarized in this to-do list for research projects. The more steps you realize, the better the success of implementation of your research projects into praxis. We really hope that the to-do list might help our partners within other research projects or even by implementing the RIU approach and its features within future research proposals. Thank you for your attention and all the best for reaching actors to transfer innovative knowledge to improve natural hazard risk management or protective forests.